Alright guys, welcome back to Algos Made Simple. This is Leetcode 424, longest repeating character replacement. It states you are given a string S and an integer K. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most K times. Return the length of the longest substring containing the same letter you can get after performing the above operations. So as you can see here, I would let the interviewer know. Okay, I understand I'm getting a string and I can make K number of changes to it in order to maximize the longest set of repeating characters. So if I had two characters and if I had four characters in a string and two characters were a certain letter, the same letter, and the other two were not, and I could change it 2 times with K, then I could maximize it out at 4. Or if I could only change 1 K time, then I could maximize it out at 3. So very easy conceptually. Look at these examples. You got S equals AB, AB. We can change two things. So obviously you can either change the two B's to A's and have 4 there, or you can change the two A's to B's and have 4 that way. Very, very easy there. We've got AA, BA, BBA, and we can only change one thing. So you're looking through here, and of course you got two A's in a row right here, and then you've got a B and an A right here. So you got one change you can make. The next letter after that's a B, so it's not going to help you there. You can change that B to an A and have 4 A's. You could go, let's see. Then you go here, A, B, A, no, B, nope. You can't do anything with that. But you go B, A, B, B, and with your one letter change, you can make that A a B, and you're at 4 there as well. So easy to understand conceptually, not difficult to understand what's being asked of us here. Very straightforward. But how can we develop a function that'll be able to figure out? Well, it doesn't need to know exactly what letter to change. We don't have to spit out the actual replaced letters, but it needs to be able to figure out how to maximize this. Well, what you could do is you want to look at these. You want to utilize a sliding window and look at the windows here. So like this one, for instance, you have 4 characters in the window. And only one character is different from the others, and you have one character to change. So that is a viable window. 4 is viable. But if we come here and look at A, B, B, and try to extend it, we've got 3 A's and 2 B's and only 1 K. So what you would do is you'd look at the window length. So where we're at on the window length, we can use it again a sliding window. Have left and right pointers, and look at the window length minus the most frequent character, and that'll tell you how many characters are left to change to make that window viable. And if that amount is over what the K is, then obviously we can't do it. So game plan would be, one, we're going to need a hash map. We'll call it count, and that'll just keep track of, okay, we've got 3 A's, we've got 2 B's, we got 5 C's, whatever, in this certain window. So it's just going to keep adding to them and taking away from it if we need to, whatever. If we update that left pointer, we're going to need, of course, a result, which will initially be set to 0. And again, I told you we need left and right pointers. The left one should be 0. The right pointer is just going to go through the range of S. So right pointer updated by range of S in for loop. And again, we'll be able to do that and go through there. And what we'll do is we'll pull the character we got coming from the right. We'll add it on the count, add the frequency to it. And before we look at that window, which the window is going to be right minus left plus 1, that's going to be our window. And that'll tell us how big our window is and what it could be possibly our new max. But before we do that, we need to see if this is a viable window. So check if window is viable. And how we would do that is this right minus left plus 1, which is our window. You would take the most frequent letter, and if that was greater than K, it would not be viable. We have to update left pointer. But if not, then we can do, if that's all good, if it's less than K, then max right minus left plus 1, and of course the old resolution. So not too hard of a problem. Let's see it all coded up here. The main thing is you just have to wrap your head around the fact that, okay, there's a window. I'm looking at the different window sizes. And when I look at these windows, I just need to check every time and see if the frequent character, or if the window size minus the frequent character leaves the same amount that is equal to k. Leaves the same amount of letters to be changed that is equal to k or less than k. It just can't be more than k. So looking at it here, you've got character replacement, if I can spell or type or anything, and you got a string and you got a k. Alright, so again, the first thing we want to do is have this count hash map. And that's just keep it up with frequencies. We're going to have a resolution 0. We're going to have the left pointer equal to 0. And then we're going to say for r in range, so that's going to be our fuel, length of s. And this is where you're going to update the count in your hash map. So you're going to say count at index SR. So you got the string and the index is the character on the right or whatever. So the right character in string. And it's going to be equal to 1 plus count.get. So what's already currently there. And if there's nothing there, we'll have a 0. So either if there's 0, it'll get up to 1. If there's, already 1 there, it'll be up to 2, 3, 4, whatever's already there, plus that 1. Alright, so then we've done that. We have our letter brought in, our new letter. What would be left to do, if we didn't have to check and actually see if it was valid, we would go ahead and just look at this left-right window and compare it to the old resolution and see if it beat it. But we have to make sure it's valid. So we'll go here and say while right minus left plus 1 minus the max of count dot values. And so that's going to give us our max letter, our max most frequent letter in this window. So if that's what we're talking about, the windows right here, and the max character, the most frequent letter is right here. And so you got that subtracted from that. If it's greater than k, then what we'll do, that means it's not a valid window. So we got to update. We got to come here at count s of left, and we're going to bring that down minus 1 because we're about to take this left and update it. So that left, the letter that wasn't left, is no longer going to be a part of this window. So that's going to update that, and then it's going to get to this while loop again and say while right minus left, so the new left plus 1 minus max count dot values is greater than k. And if it wasn't again, which I don't even know if that's possible, then it would continuously update it and update it until it could figure out that while loop and break it. So past that, if we do have a valid window that works, it's a window that has the amount of letters to be changed that is same as k or less than k, then we'll go here and say resolution equals max resolution, so our previous max, or it can be right minus left plus 1, whatever is greater. And then of course after all that, we're just going to return outside the for loop and return the resolution. So not bad at all, guys, especially once you've done this problem a couple times. It's one that is very self-explanatory and kind of flows naturally. I mean, you've got to keep account of these characters to figure out what's the most frequent letter. You need to have a resolution, obviously, and then you're just using the left and right pointers. The right pointer to look at each character and update its count, and the left pointer, when you get to a point where you cannot have a valid window, it's going to adjust as well, kind of thing. So shouldn't be too hard on this one. Again, I would say do it a couple times. Maybe have a cheat sheet that just lets you know and reminds you about this part right here. I think this part right here is the hardest part to remember, is that you need to verify that the window minus the max, so most frequent letter value, as long as that is less than or equal to k, you're good. If it's not, then you have to update the left pointer. So again, guys, thanks for watching. We're going to keep cranking these out and getting closer and closer to just knowing more and more about these algorithms. Thanks, guys.